All right, let's jump right in. What if I told you there's a simple trick that can find the absolute best hot streak in any sequence of numbers? Something that's faster than the more complicated methods, is super elegant, and it pops up in coding interviews all the time? Well, that trick is Kadane's algorithm. So first, let's frame the problem this whole thing was designed to crush. Think of it like you're trying to find the absolute highest scoring moment in a game. Imagine looking at a stock's daily gains and losses, right? How would you find that one single continuous period where you would have made the most possible money? Or maybe in a video game, what was that exact sequence of moves that led to your all-time high score streak? This is what we call the maximum subarray problem. You're given a list of numbers, some positive, some negative, and your job is to find the one continuous slice, that unbroken chunk, that adds up to the highest possible sum. It's a total classic, and the solution is just beautiful. Now, before we even think about formulas or code, I want you to picture something with me. Imagine we're sliding a paintbrush across our numbers. Trust me, this little analogy is going to give us an incredibly intuitive feel for how this thing actually works. Okay, here's our canvas. This sequence of numbers we're going to be painting over. Our brush starts at the very beginning, on -2. So right now, that's our best streak. I know, not great, but you got to start somewhere. So what happens when we move to the next number? And right here, this is the crucial choice. We get to the number 1, and we've got two options. Do we extend our old, kind of sad negative streak by adding 1 to it? That would get us to -1. Or do we just drop that old streak completely and start fresh with just the number 1? Well, 1 is obviously way better than -1, so we throw the past away and start a new streak. Easy. Okay, let's fast forward a bit. Our current streak is worth -2 when we arrive at the number 4, and it's the exact same choice. Do we carry that negative baggage forward with us for a total of 2, or do we just start fresh with 4? Of course, 4 is better than 2. This is the whole idea in action. We cut our losses and we restart our painting. And now, watch what happens. Starting from that fresh 4, we finally hit a run of numbers that are actually worth keeping. Adding -1 brings our streak's total to 3. Okay, not bad. Then adding 2 brings it up to 5. Nice. And adding 1 takes it all the way up to 6. We just keep extending our brushstroke because at every step, the running total is better than just starting over with the new number. And that number, 6, that's the best sum we have seen anywhere in this whole array so far. It's our new high score. We're going to remember that number, even if our current painting streak starts to go downhill from here. So how does this painter's intuition, this gut feeling, turn into the elegant, formal rule that makes this algorithm so darn powerful? Let's go from that feeling to a formula. You see, to make this work, we only need to keep track of one key piece of info at every step. We'll call it S of I. Now, this isn't the best sum overall. It's simpler. It's just the best possible sum of a streak that has to end at the exact spot we're looking at right now. And there it is. That is the entire logic of Kadane's algorithm boiled down to one beautiful line. The best streak ending at our current spot, I, is just the bigger of two things. Either the current number all by itself, that's starting fresh, or the current number added to the best streak that ended at the spot right before it. That's it. Extend or start over. Let's just break that down one more time. At every single number, you just ask this one question. Is this number by itself better than adding it to the streak I was just building? If the answer is yes, you start a new streak. If it's no, you keep the one you got going. See? It's just our painter's choice, written down as a formal rule. Okay, so we have the intuition and we have the rule. Now for the fun part. Let's translate this simple, powerful idea into some actual code, and you're going to see it's surprisingly direct. So before we even start looping, this first step is absolutely critical. We set both our current sum and our best sum so far to the very first number in the array. Now, this is not a small detail. So many people make the mistake of initializing to 0, but that fails if all the numbers are negative. This way, we guarantee that if the whole array is negative, we'll find the least negative number, which is the correct answer. Now, the main loop itself is just 2 lines of pure logic. For every number after the first one, we just apply our rule. The new current sum becomes the maximum of either starting fresh with this number, x, or extending our old streak by adding x to it. Then we just do a quick check. Has this new current sum beaten our overall best sum? If it has, we update our high score. And honestly, that's the whole thing. We just walk through the array one time, making that simple choice at each step. No complicated data structures, no weird recursion, just one clean pass. So why is this simple approach so famous? Why is it a must-know? Well, it's because when it comes to performance, this elegant little algorithm completely dominates all the other ways you could solve this. It's not even a contest.
Just take a look at this comparison. A brute force way, where you check every single possible subarray. That gets incredibly slow, really fast. Even a more clever divide-and-conquer strategy is still slower. Kadane's algorithm just stands alone with its perfect linear time complexity.
And this is so important, it deserves its own moment. ON time. All that means is that the time it takes to run the algorithm grows in a straight line with the size of the input. It's the absolute best you can possibly do because you have to at least look at every single element once to know you found the max, right?
But wait, it gets even better. The algorithm uses O of 1, or constant space. This means it doesn't matter if your array has 10 numbers or 10 million. It only ever needs a couple of variables, current sum and best sum, to do its entire job. It is incredibly memory efficient. So let's just recap what makes Kadane's algorithm so essential. It solves the problem in a single pass. It uses a tiny, constant amount of memory. It's all built on that one simple, intuitive choice. Do I extend my current streak, or is it better to start a new one? And once you master this pattern, it opens the door to solving much more complex problems, like finding the biggest subrectangle in a 2D grid. Ultimately, the real takeaway here is this. Kadane's algorithm isn't just a solution to one problem. It's a fundamental way of thinking. It's about knowing when to carry your momentum forward and when it's time to cut your losses and reset. It's a powerful, dynamic pattern. So the real question is, now that you know it, where are you going to spot it next?